In the government's latest response,
you must stay at home.
Master of the house, doling out the charm.
It's very important that everyone
know that you are not alone.
So in this video, we're going to have a look at the nomenclature of, or naming, of like alcohols or alkanols. Now, an alkanol is when you have an alkane in particular with an OH group, a hydroxyl group off the side. Everything else is just an alcohol, but an alkanol is that in particular. And both those words, you will see them used interchangeably. They're not interchangeable, but yeah, that's for that. Okay, so our learning goal is to be able to name and draw some alkanols or alcohols, and to be able to identify if an alcohol is a primary, secondary, or tertiary alcohol or alkanol. So even I've done it. All right, so here's your vocabulary. I get you to pause the video here, maybe hit subscribe and like, and write down these words and the definitions, just so you've got something to refer back to as we move through the lesson, so you can keep coming back to it. So our functional group is this here. So R is the alkane chain, or the chain, the carbohydrate chain. Then, not carbohydrate, I've done it again. It is the hydrocarbon chain. And here we have the OH group. Okay, so this OH, or this hydroxyl group, that is our functional group. And as long as it's higher in priority than whatever else is on there, that's what we name it after. The general formula for an alcohol is CnH2n plus 1 OH. So we keep that H separate. We keep that so we know that it's part of the OH group. But if we were just writing the strict molecular formula or empirical formula, that H would of course be in with the other group. But when we're drawing a molecular formula or structural formula, we always keep it separate. So here we have an alcohol, and here we have another alcohol. And let's have a look at the rules for naming these. So the first thing we want to do is we want to identify the functional group. In this case, it's an OH, ROH, and it gives the suffix, which is ol. Then we identify the longest parent chain. In this one, it's 3. And in this one, it's 1, 2, 3, 4. It's a skeletal structure. Maximum number of multiple bonds, carbons, as always. This gives the prefix. So for this one here, we're going to have 1, 2, 3, prop. This one here, 1, 2, 3, 4, but. Number the parent chain to give the hydroxyl group the lowest possible combination. So we would start both of these from the right-hand side. Then identify any double or triple carbon bonds. None of these today. That gives us the an, ene, or ine. So these are an, so we now know it's a prop. For the first one, prop, and 1 ol. Identify any side chains, give them the il at the end. This one here, oh, actually, hang on a second. Add prefixes di, tri, and tetra to the identifier of any components. Okay, so here we have 2 hydroxyl groups. So it would be 1, 2, because we want to give it the lowest number possible. So it's but. So butane, because there's only single bonds. Butane 1, 2, diol. Okay, so that's how we would name that. And position numbers as always. So 1, 2, 3, 1 ol, propan 1 ol, 1, 2, 3, and that's 1, 2 diol, and butane diol. So now we have our 4 examples. So let's go through these. So the first one we number. Remember we want the OH to have the lowest possible numbers. So we have 1, 2, 3, 4, 5. So it's pentan 1 ol. Okay, so here we are again. 1, 2, 3, 4. So it's butan 1 ol, but that's not all of it because it's got this little section down here. And that's a 2-methyl. So it's a methyl, but it's on the 2 carbon. And we put those together, and that gives us 2-methylbutan 1 ol. Okay, here we have a propanol because it's got the 3. Okay, propan 1 ol. And again, the OH has come off the primary carbon. Then we have these 2 groups here. And they are methyl groups. So there's 2 of them, so it's dimethyl. And they're both on the number 2 carbon, so it's 2,2-dimethyl. Put all that together, and we end up with 2,2-dimethyl propan 1 ol. It's fun, isn't it? Like, I really enjoy this. So now let's have a look at this one. This is a slightly simpler one. So it's 4 but You beauty. No, 4, so it's bute. Sorry, I don't know why I did that. Bute, and it's going to be an ol. So it's bute and 1 ol. And there's 1 methyl group here on the 3rd carbon, 3 methyl butane 1 ol. So primary, which is this 1 degree, 2nd degree is secondary, 3rd degree is tertiary. So these are our primary, secondary, or tertiary alcohols. And this actually affects the reactivity. We're not going to go into that today, but just know that's coming up. So primary alcohol is where the OH is connected to essentially the terminal carbon, like the carbon itself only has 1 attached. Secondary carbon alcohol is one where it's attached to a carbon with 1 other off the side. A secondary carbon is not a terminal carbon, it's like an interstitial carbon. So if we come over here, so we've got this carbon here, we've got R groups off this way and R groups off that way. So it's got 2 R chains hanging off it, which would all probably make 1 R chain. And we have our tertiary alcohol, which will often have a methyl group hanging off the side or something like that, like some form of alkyl side chain. So we've got 2 carbons here. So we can see this down here, right? So we've got this alcohol, which would be propane. It's called tertiary or tert-butanol. We would call this one 2 methyl propan 2-ol. Here we'd have propan 2-ol, and here we'd have ethanol because it's only got 1 off the side. So that's our primary, secondary, and tertiary alcohols. If you have any questions, put them in the comments below. Don't forget to subscribe so you can keep up with everything we're doing. We'll get back to any questions you leave us as soon as we can. Thanks for watching, and we'll catch you next time. Bye now.